Hello and welcome to the Property Damage podcast series on modern methods of construction. Today we'll be covering the issues surrounding the use of cavity barriers in buildings with modern facades. I'm Matthew Lowry, a solicitor at BLM in Liverpool.
I'm Laurie McConnachie, a solicitor at BLM in London.
We're delighted to be joined by Sam Morley, Senior Associate and Forensic Architect at Hawkins. Hawkins provide forensic investigation services to insurers, loss adjusters, brokers, and a variety of other organisations. Thanks for joining us today, Sam. Today we'll be talking about the risks associated with modern facades in construction, and in particular the issues around absent or poorly installed cavity barriers in order to consider the fire risks facing the insurance industry. In 2020, fire claim submissions during the UK lockdown in both domestic and commercial properties increased by 40%. The investigations following the Grenfell Tower fire have brought about awareness of the issues surrounding fire prevention systems in buildings with modern facades. As insurers will already be aware, properties irrespective of their facade must be constructed in a manner which is compliant with the appropriate building regulations. Historically, and before the Grenfell disaster, the focus was on the distance between adjacent buildings when considering the risk of external fire spread. Only after Grenfell has the risk of fire spread across the facade of a building been in the forefront of people's minds. Due to the increasing creativity, both in design and materials used to construct buildings, there are an increasing number of new considerations for insurers when assessing their risk exposure in respect of fires. Sam, could you please explain the types of modern facades you're seeing commonly used in the construction industry today, and which ones have, in your experience, proved problematic, particularly with regards to fire performance?
Rain screen cladding and curtain walling are two very common facade systems currently used in construction. Whereas curtain walling systems comprise glazed units that span from floor to floor, I'm going to focus today on rain screen cladding. These consist of a lightweight cladding panel with open horizontal and vertical joints supported on a vertical bracket system, which allows for ventilation and drainage between the cladding panel and the thermal insulation. The thermal insulation and cladding support brackets are fixed back to a solid substrate, which could either be a cement particle board or metal stud-work in the case of new construction, or masonry or concrete panels if the rain screen is being applied to an existing building to improve its environmental performance as part of a refurbishment project. This system has many advantages, including the relative lightweight of the system, which reduces the need for complex structural support which would be required for a solid masonry facade. In addition, the bracket system is adjustable to take account of any existing misalignment. It is fast to install. It does not require heavy equipment. Thick layers of insulation can be accommodated, improving thermal performance, and there is a vast choice of cladding finishes. However, there are a number of particular fire performance issues associated with rain screen cladding systems that should be considered. If we look at Part B of the building regulations, which deals with fire safety, within this, B4 sets the functional requirements for external fire spread as follows. The external walls of the building should adequately resist the spread of fire over the walls and from one building to another, having regard to the height, use and position of the building. So firstly, the individual parts of a rain screen cladding system should meet the required level of combustibility. And secondly, there is a need to resist fire spreading. The issue with rain screen cladding systems regarding the second requirement, resisting fire spread, is that there is a hidden vertical cavity, that area that I previously mentioned for ventilation and drainage between the cladding and insulation, which fire can spread up unseen like a chimney. It is difficult for firefighters to fight a fire in this space, as the cladding prevents firefighting water getting to the blaze. This issue is normally resolved by including cavity barriers at regular intervals to combat the spread of fire.
Thanks, Sam. Where does responsibility for cavity barriers lay?
There are design and workmanship responsibilities to consider when assessing who is responsible for the cavity barrier performing as required. Typically, the architect, as lead designer, would have initial responsibility for the facade concept at the early stage of the project, and decisions taken at this stage will have an impact later in the project. For example, it's important that consideration is given to how cavity barriers may work when freezing a design for a plan application, as after this point the design of the elevation will then be set. If this involves large projections or irregular shapes leading to a complicated irregular cavity width, then bespoke cavity barriers may be required. This will need to be considered during the detailed design process to avoid a situation that is unbuildable or does not meet building regulations using standard off-the-shelf products. As the project progresses, it is likely responsibilities for the design of cavity barriers will switch to other members of the design team, including possibly a facade engineer with input from a fire engineer. Once a contractor is appointed, the detailed design of the facade may pass to the facade contractor based on a performance specification provided by an architect or a facade engineer. The contractor is responsible for workmanship and ensuring that the installation of the cavity barriers complies with the contract.
So what do you think can be done to avoid the issues you're seeing?
To give clarity to who is responsible, it's useful to compile a design responsibility matrix, which would set out which party is responsible for each element of the design at each RIBA work stage and the level of detail required. A specification should be required, preferably using an industry standard format such as MBS, based on the Uni-class numbering system, which incorporates performance requirements so that it is made clear to the contractor what is required of them and the relevant standards that apply to the work, including the strategy that is being followed to comply with the building regulations. Early engagement between the design team and the facade contractor can help ensure the solutions are feasible and tested. This should be on a formal basis through a specific process such as two-stage tendering as part of the procurement of the project. Checks should be made to ensure those involved in the project are competent to carry out the work, including previous project experience and qualifications. When the project is on site, an independent inspection of facade works by either the design team retained by the client or a dedicated clerk of works will lead to a proactive approach to defects rather than reactive after completion, with the client needing to pursue the contractor.
Thanks, Sam. How will the new building safety bill help? And is there any other guidance being considered at the moment that may go some way to reduce the risks property owners and insurers face?
The Building Safety Bill includes a number of provisions that are intended to help ensure that these issues described earlier regarding cavity barriers are addressed during a project so that a safe and compliant building is delivered. This includes identifying new roles within the project team with specific duties related to compliance with the building regulations, which cover the design, construction and ongoing management of the building in a similar way to the CDM regulations, which designate statutory duties in relation to construction, health and safety. At particular points in the project, before planning submission, prior to start of works on site, and at completion, those holding these duties, the duty holders, must agree that they are all satisfied that the project can proceed to the next stage. This should allow all members of the project team to raise any concerns that can then be addressed as necessary to avoid unresolved issues being hidden until later, which can then become a much bigger problem. Another change is the requirement for a fire statement to be submitted with a planning application to outline the fire strategy of the building and route to compliance with Part B of the building regulations. This requirement will bring detailed design issues such as cavity barriers and external fire spread into design team conversations and design coordination at a much earlier point in the project than is currently typical. There are also proposed amendments to the Architects Act, which covers the regulation of architects that are intended to improve the competence of architects. There will be much tighter controls on the quality of information related to building safety, which will correspond to the new gateways described earlier. The need for fire safety information is currently covered in Regulation 38 of the Building Regulations. The Building Safety Bill will strengthen this requirement. There is a draft British standard BS 8644 Part 1, which sets out how fire safety information should be managed digitally, including requirements for BIM during the life cycle of a building, which aims to address the need for a golden thread information described in the Hackett report. There is also another standard currently under development by BSI, PAS 9980, which aims to set out a methodology to assess the fire safety of the facades of existing multi-occupancy residential buildings and how to determine appropriate remedial works.
Thanks, Sam. Cavity barriers are essential for maximising fire performance, and their suitability for the building needs to be considered at the design stage. However, the ever-increasing variety of materials used and the complex geometry associated with the use of some materials means that insurers are increasingly seeing issues with these buildings, which have poorly installed or inappropriate cavity barriers and insufficient fire prevention or fire stopping measures.
Whilst compliance with building regulations may not reassure insurers, there are some steps that insurers will be able to take to reduce their risks. For example, 1. Ensure the building is compliant with the Building Safety Bill, as there will have been scrutiny of fire safety measures at the planning, prior to work starting and completion stages. 2. Inquire as to the type of facade used and whether buildings are deemed a higher risk. Take steps to obtain further information and evidence in regards to the fire safety measures implemented in the build. 3. In respect of existing buildings, insurers could require independent fire safety assessments to be undertaken in compliance with the currently under development new British standard, which will go some way to identify existing defects.
Thanks very much to Sam Morley of Hawkins for his time today. Sam, this is extremely useful, and hopefully we'll be able to see much more information come to light in the months ahead to allow both insurers and homeowners alike to be able to be better informed on the construction of their properties, and to ensure the appropriate steps can be taken to ensure risks are minimised for everyone involved.
We're going to be covering some of the topics that we've discussed today in more detail in future episodes of the Property Damage podcast. We'd love to hear your observations and comments on the content of this episode, so please do send them through to us at propertydamage@blmlaw.com. It just leaves me to say thank you for joining in with us today, and we look forward to you tuning in for the next episode.